All right, so let's look at quadratic inequalities in one variable. So this basically says that we've set y equal to 0 because we want to solve. But because we have an inequality, we're not going to have a single or even two answers for x. We are going to have a range of answers for x. It's either going to be less than or equal to, greater than or equal to a number. So in order to do that, remember that we have our little saying that we did that's going to help us graph our inequalities, that less than is and greater than is or. We said that less than could be written as less than, and so and kind of is in the word. And if you write greater with an O instead of an E, then you can get the or in greater. All right, so the first thing we're going to do is change our inequality to an equation and then use any of the 5 methods that we've used in class to solve. And then whatever solutions we get, whatever x values we get, are going to be our critical values. And we want to plot those on a number line and then decide if our lines and arrows go opposite directions or if they're in between based on our inequality symbol. Finally, we'll write our solution in inequality form by interpreting our number line. So I know that's not going to make a whole lot of sense until we get started on an example. So let's look at a couple of examples. All right, so we are going to solve these quadratic inequalities algebraically. This first one, the thing that jumps out to me is that I don't have a middle term. I don't have an x term. So that means that I can probably use a couple of different things. Without rearranging this equation, I could use square roots. If I wanted to rearrange the equation and move the 100 to the other side, then I could look at using our difference of squares, or I could even use factoring or quadratic formula, but I would just have my b term equal to 0. So honestly, this is kind of a special one where basically any of our techniques would work. But I don't want to have to rearrange, so I'm just going to use square roots. This is an or because it's a great or. It's greater than, so it's a great or. And I'm ready to start solving. So remember, set it as an equation first, and then use any of our methods. I said I was going to use square roots, and I can do that because everything on the left side is a perfect square, and then I have a number on the right. So I'm going to say that 16 squared is 4, and x, or the square root of 16, is 4, and the square root of x squared is x. On the other side, remember, we always have to have a plus or a minus to account for the fact that we are undoing an x squared, and it could have been a positive or negative number for x. And then square root of 100 happens to be a perfect square of 10. So 4x is equal to plus or minus 10, and I continue solving by just dividing both sides by 4. And so I'm going to get x is equal to plus or minus, and I want to go ahead and simplify 10 over 4. I noticed that I could divide both of those by 2 and get 5 over 2. So those are my critical values. These are not my answers. They are my critical values on a number line. So if I define 0 as here, I can put 5 over 2 there. It's 2.5. So 5 over 2. And then negative 5 over 2. So now I want to plot these points. I'm going to use open circles, not closed up circles, because I don't have the or equal to part. Remember that unless I have the extra line underneath, I don't do the extra step of filling in. Because I have an or, we're going opposite directions. Remember, or means we go opposite directions. All right, so now we're just ready to interpret our number line and write our final inequality. Because we have two separate lines, we're going to have to write this as two separate parts. X is either, I put equals, but it's not equals. X is less than, because I'm going to the left, less than is left, less than negative 5 over 2, or x is greater than a positive 5 over 2. And that is my final answer based on my inequality.